Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. In the past few lessons, we learnt how cryptocurrencies mimic the property of fiat currencies. This lesson is a recap lesson and is divided into 3 parts. The first part of the lesson is a recap of various terms that we have learnt in the course so far. The second part of the lesson is the recap of how cryptocurrencies function. The third part is some reflections on the role of rules in the functioning of cryptocurrencies. We can begin with the term blockchain itself. We learnt that the term is derived from the chain of blocks that form the official records of the network. However, there are 2 contexts in which it can be used. In the narrow sense, it refers to a network, and in a more comprehensive sense to a set of technologies. We will look at each definition in turn. A blockchain network is a network of computers that store the same information concurrently by propagating information to each other, and operate by a set of rules that is encoded in software specific to that network. For example, Bitcoin and Ethereum are both blockchain networks, and have their respective software implementations. This is the definition with which we began this course. But now that we know much more, we can define blockchain more comprehensively as a technology. The term blockchain technology refers to a set of technologies and software-enforced rules, which are brought together to perform certain functions. One of the functions is to replicate a currency and payment system. But as we will learn in the upcoming lesson, that need not be the only function. Next, we will look at what these technologies and rules are. The term blockchain technology encompasses the following elements. We can think of these as Lego blocks of the blockchain. First, a peer-to-peer computer network in which each node shares information with others via a gossip protocol. No node is superior to other. Hence, it is peer-to-peer. Second, changes to data in the network occur via transactions that are batched together in blocks, which in turn are linked via a chain of blocks. Third, transactions are authenticated via digital signatures based on private and public keys. We will continue with listing these Lego blocks in the next slide. Fourth, a consensus mechanism exists by which each node in the blockchain network agrees to a set of records as representing the truth. Examples of consensus mechanism is the proof of work mining and longest chain rule. Fifth, rules are enforced through a system of incentives like fees and block rewards instead of top-down diktats. Finally, all nodes in the network use a software program that encodes the rules of that specific network. For example, the software program on a Bitcoin node is different from what runs on an Ethereum node. A node is a computer on the blockchain network. In a permissionless blockchain, anyone can become a node in the network by installing software specific to that blockchain network and connecting to a few other nodes of the network. A public or permissionless blockchain is a blockchain network that allows any individual to become a node in the network by installing software to her computer. The blockchain, in its original vision, was conceived as permissionless. A token is a physical or digital symbol that is ascribed economic value by those acquiring them. A crypto asset is a digital token that resides in a blockchain network. Throughout this course, we will use the term token and asset interchangeably. A cryptocurrency is a type of crypto token that is designed to mimic the properties of fiat currency. These properties include segregated accounts, account security, transferability of value between accounts, and finally, prevention of double spending. The relationship between cryptocurrency and blockchain network is similar to the relationship between currency and country. Bitcoin is the currency of the Bitcoin blockchain network. Ether is the currency of the Ethereum blockchain network. The blockchain address is an identifier used to segregate holdings of crypto assets, of which cryptocurrencies are a type. The blockchain address is equivalent to a bank account or brokerage account. In the next lesson, we will learn that the blockchain addresses can hold other types of information apart from crypto asset holdings. For instance, they can hold software code. Custody of an asset refers to the responsibility of ensuring that the ownership of the asset is not transferred to an illegitimate owner. Custody and ownership are closely related. The responsibility of a custodian is to prevent loss of ownership from theft. Ownership is proven in 2 forms. The bearer form means that ownership of the asset is evidenced by the possession of a physical or digital artifact. An example is a cashier's check, which is payable to the bearer of the check. A digital equivalent is a virtual prepaid card. The registered form means that ownership is evidenced by inclusion of the owner's name in a register that is recognized to be the source of truth. An example is a motor vehicle title. The ownership of crypto assets is proven by the knowledge of the private key of the blockchain address that holds the crypto asset. Hence, crypto assets follow the bearer form of ownership. Public key is an identifier that enables the owner of a blockchain address to prove she knows the private key to the address without revealing the private key. Each blockchain address has a public key and a private key. Unspent transaction output or UTXO is the unspent amount of payment received in a blockchain address. Running a node refers to joining a blockchain network by installing the software program of that network and using the software to execute some or all of the tasks expected from nodes. A wallet is a software application that allows non-technical users to transact in crypto assets without having to run a node. The wallet allows the user to store her private keys securely and transfer crypto assets like cryptocurrencies to others. In a custodial wallet, the private keys are held by the wallet software provider. In a non-custodial wallet, the knowledge and responsibility for safekeeping of the private keys exists with the user. Cold storage refers to storing private keys on an object that is not connected to the internet. The object could be a piece of paper, an offline computer, or a hardware wallet. The purpose of cold storage is to prevent hacking of the private key. A block is a batch of transactions processed on the blockchain that are added as a group to the official record of transactions on the blockchain. Block creation time refers to the time interval between the creation of two blocks. Block height of a block refers to the number of blocks since inception that precedes that block. Confirmation refers to the inclusion of a transaction in a block. Number of confirmations pertaining to a transaction refers to the total number of blocks that were formed after a transaction was confirmed, including the parent block of the transaction itself. Mempool, short for memory pool, refers to the universe of transactions that have been authenticated but not yet confirmed into a block. Each node, after it authenticates a transaction, pushes that transaction into its mempool. Block header refers to a set of attributes of the block that are recorded as metadata about the block. Miner is a person or entity that performs the task of confirming transactions into blocks. Nonce is a random number in the block header that a miner must guess to get the right to form the next block. The correct guess is called the golden nonce. Mining pool refers to a group of people or entities who pool their computing power to guess the golden nonce and share the rewards of mining. Block reward refers to the issue of newly minted crypto tokens to miners as a reward for mining. Coinbase is the input to the transaction that pays out the block reward. While the inputs to other payments is AUTXO, the input to a block reward is Coinbase. Proof of work describes the process of repeatedly running calculations to secure the right to form the next block in blockchain. The work in proof of work refers to the computing effort spent in guessing the golden nonce as part of mining. The golden nonce is the proof of work. In this section, we will learn how cryptocurrencies function. The functioning of cryptocurrencies can be understood in terms of two workflows: the account opening workflow and payments workflow. Next, we will look into each. Any user can generate a blockchain address, private key and public key by running a software program that executes the mathematical functions required by the blockchain network. Connectivity to the blockchain network or even the internet is not required. The inherent mathematical properties of the functions used imply that the same address and keys are not generated twice. Non-technical users can use wallet application to generate blockchain addresses and associated private and public keys. A new blockchain address is not reflected in the blockchain network unless a transaction references that address as a source or destination. A payment can be initiated by generating a payment message with an attached digital signature. Creation of the payment message and generation of digital signature can be done by running a software program that executes the required mathematical functions, without being connected to the internet. Most non-technical users can initiate payments using software that performs the mathematics necessary to generate the digital signature. A payment initiator can broadcast a payment message to the blockchain network by either connecting to the network as a node or using the services of an intermediary like a wallet company. A payment received by the blockchain network is authenticated by the nodes in this network. Among other things, this includes validating the digital signature. After a payment is authenticated, it is added to the mempool of each node. Mining nodes pull up transactions from the mempool into candidate blocks. The miner who correctly guesses the golden nonce first forms the next block. The successful miner propagates the newly mined block to all the other nodes in the network. Each of the other nodes independently verify the block and add to the chain of blocks. If a receiving node finds that the new block received refers to a different blockchain, it follows the longest chain rule. We will end this section by reflecting on a foundational design principle of cryptocurrencies. Cryptocurrencies are designed to function on the basis of highly standardized rules, which are systemically enforceable and are established by consensus. The primacy of rules is the foundational design principle of cryptocurrencies. Next, we will peel the onion on this design principle further. We can ask 4 questions when comparing the role of rules in fiat money and cryptocurrency systems. First, do rules exist to govern the execution of a process? Second, are the rules implemented in a standard manner? Third, are the rules defined in a way that they are systemically enforceable? Finally, are the rules made by central parties? Next, we will look at each question in turn. Let us consider the first question. Do rules exist to govern the execution of a process? We can take a couple of examples. Take the process of authorizing a payment. The rule in fiat money is that the payer must prove that she owns the account. A similar rule exists in crypto money. Another example of a process is the issuance of new currency. A common rule in fiat money is that only the central bank can issue new currencies. In cryptocurrency, the rule is that new coins are issued by a software program based on a defined logic. When answering the first question, we can give a green tick to both fiat money and cryptocurrencies. Indeed, the global monetary system could not operate without rules. Hence, it is not surprising that rules govern processes in fiat money. The second question is whether the rules are implemented in a standard way. At this point, we can distinguish between parent rules and child rules. Consider the rule that governs the process of authorizing a payment. The parent rule is that the payer must verify that she is the owner of the account from which payment is made. The rule is implemented in many ways. For instance, the wet signature on a check must match a specimen signature. The PIN entered in a card reading machine must match the PIN on record. We can call these child rules. In fiat money, there are many variations in child rules for a given parent rule. Consider the parent rule that the payer must verify that she is the owner of the account from which payment is made. Child rules include wet signatures, PINs, passwords, user IDs. Further, different banks may have bank-specific add-on rules. For instance, how much you can withdraw from an ATM on a given day may vary by bank. In cryptocurrency, as long as the digital signature is valid, the payment is authorized. While rules may be somewhat different across cryptocurrencies, within one cryptocurrency system, they are implemented in a standard way for everyone. On the criteria of standard rules, cryptocurrencies are by far the superior alternative. Systemic enforceability refers to the ability to enforce rules via software programs instead of human beings. Red light cameras are an example of systemic enforcement, while tickets issued by a policeman is manual enforcement. Consider the following rules. The PIN entered on a card reading machine must match the PIN on record. The wet signature on a check must match a specimen signature on record. A suspicious payment transaction must be reported to the government authorities via filing a suspicious activity report. The first rule is easy to enforce via a software program. However, the latter two are more difficult to automate, though over time, the use of artificial intelligence may make it feasible. Even then, it may not be cost-effective to apply advanced technology to administrative tasks. In cryptocurrencies, on the other hand, rules are enforced by software. Consider the following rules. The digital signature must be valid. An available UTXO must support a payment. The node that gets to form the next block is the one which guesses the golden nods. These rules are all enforced by a software program. Node operators on the blockchain network install software that performs these validations. They are not authenticating transactions manually. In cryptocurrencies, rules are encoded into software. Rules are implemented by executing the software program. Human intervention, to the extent required, is focused on modifying the code. The modification of the code occurs in accordance with an agreed-upon governance mechanism. In the system enforceability criteria, cryptocurrencies are far more advanced than fiat money. While even in fiat money, many rules are automated, the level of automation is much higher in cryptocurrencies. Finally, we get to the question of who makes the rules. In fiat money, the rules are set by central parties like governments, banks and network utilities like Visa and MasterCard. In cryptocurrencies, the rules are initially set by the founders of the blockchain network. Any changes to the rules can only occur if a majority of the nodes accept the changes. The governance mechanism by which this occurs for public blockchains like Bitcoin and Ethereum is highly unstructured and decentralized. If we compare the role of decentralized rulemaking, it is minimal in fiat currency. In cryptocurrencies, on the other hand, the role of central parties in running the network is minimal. While the founders of public blockchain networks like Satoshi Nakamoto and Vitalik Buterin play a centralized role in the initial design and setup, once the network is running, the founders do not exercise any formal control. We can now synthesize the discussion on rules in fiat versus cryptocurrencies. While both fiat and crypto money systems are governed by rules, the rules in cryptocurrencies are more standardized, more systemically enforceable, and cannot be changed via centralized diktats. The rules governing a specific network like Bitcoin or Ethereum are unique to that network, though there are thematic commonalities across networks. As an analogy, we can think of banks in different countries. While each country has its own regulation, a thematic similarity across all countries would be restrictions preventing banks from making high-risk investments. The set of rules governing a network is often referred to as protocol. For instance, people may say the Bitcoin protocol or the Ethereum protocol. In cryptocurrencies, one reason that the rules can be coded into software programs is that they heavily rely on mathematics. Next, we will recall some examples of math used in the account opening and payments workflow. In the account opening workflow, here are some of the mathematical functions we encountered. Generation of a random number, which is designated as the private key. Elliptical curve multiplication for conversion of private key to public key. Hashing algorithms for the conversion of public key to Bitcoin address. Conversion of large numbers from decimal format to base 58 format. In the payments workflow, here are some of the mathematical functions we encountered. Digital signature creation and verification using hashing algorithm and ECDSA. The discovery of the golden nonce that satisfies specified mathematical criteria. This is also referred to as proof of work mining. The adjustment of difficulty level to enforce a consistent block creation time. The use of the longest chain rule to resolve soft forks. In the past few lessons, we learned how cryptocurrencies mimic the four properties of currency. We now have a comprehensive understanding of how they function. However, our main frame of reference on cryptocurrencies was Bitcoin. In the next lesson, we will cover the second oldest blockchain network after Bitcoin, namely, Ethereum and its cryptocurrency called Ether.